Good morning, students. Today we are going to discuss an important topic in chemistry, that is the Boyle's law, complete explanation step by step. Okay. First of all, we are going to see the law. At constant temperature, the volume of a fixed mass of a gas is inversely proportional to its pressure. Okay. Then we are going to see the derivation. In this law, there are two constant and two variables. First of all, the temperature of the gas, that is taken as T, that is a constant. Then the mass of the gas, that is taken as M, that is a constant. Then volume of the gas, that is taken as V, that is a variable. Then the pressure of the gas, that is taken as P, that is a variable. Therefore, temperature and mass are constant and volume and pressure are variables. So, volume is inversely proportional to pressure. Now, we are going to apply the terms. Then volume is taken as, it's well known that V, and pressure is taken as 1 by P. So, this is equation number 1. Okay. Then, there is a proportionality. To eliminate the proportionality, V is equal to K into 1 by P. Okay, where K is a constant. So, now this P go this sides and multiply with the V. Therefore, V into P is equal to K. It means the product of volume and pressure is a constant. Okay. Now we are going to imagine an experiment. In this experiment, container is filled with a gas, then the pressure that is acting on the gas through the piston is equal to 1 atmosphere, then volume is equal to 2 liter. Now pressure is increased, volume is decreased. So now P is equal to 2 atmosphere and volume is equal to half liter. Again the pressure is decreased and volume is increased. Now pressure is equal to 1 atmosphere and the volume is equal to 2 liter. So it's well known that in these conditions, if volume is equal to 2 liter, here it becomes equal to 1 liter. So that is equal to 1 liter. Okay. Then if the volume is increased, pressure is decreased. If the pressure is increased, volume is decreased. So by observing these two figures, we know that the volume of the given mass of the gas is inversely proportional to its pressure. So, by using this simple diagrammatic explanation, we are going to derive another derivation. So, here V into P is equal to K, that is equal to equation number 2. Then, based on this experiment, now we are going to see the initial volume is equal to V1, initial pressure, that is equal to P1, final volume is equal to V2, final pressure, that is equal to P2. So by using the equation number 2, we are going to apply the initial volume and the initial pressure. So the product of V1 into P1 is also equal to constant, that is equation number 3. Then the product of V2 into P2 is also equal to K by using V into P is equal to K. That is equation number 4. By using the relation final volume and final pressure. So it's well known that the product of V1 into P1 is equal to K. The product of V2 into P2 is equal to K. Therefore, by equating, equations 3 and 4. Equation 3 and 4. So it's well known that V1 into P1 is equal to V2 into P2. So now we are going to have the equation V1 into P1 is equal to V2 into P2. This is the equation number 5. In equation number 5, the V2 comes here and P1 goes there. As a result, V1 divided by V2 is equal to P2 divided by P1. This is equation number 6. Then it's well known that the density of a gas, density of a gas is the ratio between the mass of the gas divided by volume. So it's well known that it's equal to mass divided by volume. Therefore, it gives the density is equal to m by v. But now we are going to have we want the volume. Therefore, volume is equal to mass divided by the density. Here, mass of the gas is a constant here. Therefore, m is a constant and d is a variable. Now, we are going to find out the V1 value. V1 is equal to m by d1 and V2 is equal to m by d2. Now applying the value of V1 and V2 in the equation number 5. Apply the values of V1 and V2 in equation number 5 here. So as the result becomes here V1 is equal to m by d1 into P1, that is also equal to V2 is equal to m divided by d2 into P2. We are applying the value of V1 and V2 here. So there is m, both are cancelled each other. Then P1 divided by T1, that is equal to P2 divided by D2. So this is equation number 7. So this is various mathematical form of the Boyle's law. Now we consider the first equation. In the first equation, volume and pressure of the gases are related. In equation 1 and 2. In the equation 3 and 4, different volumes and different pressures are equated. That is V1 into P1 equal to V2 into P2. Then in the equation number 7, the pressure and density of the gases are also equated. So this is a very important law. Now we are going to see the graphical representation of the Boyle's law. Now we are going to see the graphical representation of the Boyle's law. So it's known that at constant temperature, the volume of a fixed mass of a gas is inversely proportional to its pressure. So the volume of the gas is inversely proportional to the its pressure. So we are going to take the two axes, namely x and y. In the x-axis, we are going to take the reciprocal of volume in liter. In the y-axis, we are going to take the pressure in atmosphere. So in the reciprocal value, both are linearly increases. If P increases, then 1 by V also increases. If P decreases, 1 by V also increases. Students, here, watch carefully. If P is increases, V is decreases. Okay? Then, if P is increases, if we are going to take the reciprocal of volume, that is also increases. If P is decreases, the reciprocal of volume, that is also decreases. This is a relation in the reciprocal value. Okay? Therefore, we are going to get a straight line that passes through the origin. Then we are going to take the next graph. In the x-axis, we are going to take the pressure in atmosphere. In the y-axis, volume in liter. Therefore, if the volume increases at the same time, pressure also decreases. It means it's nearly equal to zero value. Okay. Then, if the pressure is increases, then volume of the gas also decreases. So, this is the relation between the P and V. So, it's well known that I have already told you, if the pressure is increases, volume is decreases. Then, if the pressure is decreases, volume also increases. Say for example, if pressure is equal to 2 atmosphere, then volume is equal to 1 liter. Okay? If pressure is decreased by the 1 atmosphere, then volume is increased by the 2 liter. So this is applicable for the graph number 2. It means this graph. So we are going to get a parabola like the curves. Here we are going to get the straight line. Okay. This is Boyle's law, and therefore from the various expression, therefore this law simply called in a single term, that is a pressure volume relationship. Pressure volume relationship of a gas. So this is a one sentence form of a Boyle's law, because the Boyle's law explained what are the relationship between the pressure and the volume of the given mass of a gas. Okay. Now I am going to show you how the pressure and the volume are inversely relational by doing a simple experiment in this video. Now look at the doll. This doll is very much used for me to demonstrate the Boyle's law. Okay. Now just look at the volume of the doll. Okay, it's nearly 15 centimeter height. Okay, it has a definite length, breadth and height. So it has a definite volume. Now there is no pressure, therefore volume of the doll is somewhat large. Now I am going to apply the pressure on both top and bottom of the doll. So now watch carefully what will happen. Okay. Now volume of the doll is reduced by its half. So this is well known, because the same concept is applied to the pressure. If volume is increased, pressure is decreased. If pressure is increased or pressure is given by my hand, then volume of the doll is decreases. Now I remove the pressure. See what will happen. Now we are going to get the original volume of the doll again. It's a beautiful one. Okay. Watch this video, use the video and share with your friends. Thank you, student.